Hello, Chemistry of Earth and Space Science. Still lesson one, but now it's the second part of balancing chemical equations, just showing a little more practice. Still the same objectives as before, applying the law of conservation of mass to balance the equations and using coefficients to do that. So a reminder from our chemical reactions lesson is that if we have a word equation, a description, which is what we're going to have on this particular video, then the way to go about converting a word equation to a chemical equation starts with writing each one of the compounds correctly and then using the subscripts as you need to get each compound to have the correct number of each atom. Don't forget, in regard to bromine, iodine, nickel, bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine, that when those elements are by themselves, not part of a compound, by themselves, they will have a subscript of a 2 because they only exist as diatomic molecules. We lay it out to have the pluses and the arrows to make it look like a balanced equation, and we're good to go. Then we can balance it. So let's check our examples for this particular video. So first example has aluminum hydroxide reacting with sulfuric acid to produce aluminum sulfate and water. So we know that aluminum hydroxide is Al, hydroxide is OH. I can already tell I'm going to need a different color here. Let's go with the yellow. So Al, OH. Aluminum has a +3 charge. So hydroxide being has a -1 charge, we need 3 of them. That's not 3. That's the 3. Let's get closer to the 3. There we go. 3's are going to be okay. Sulfuric acid. Something I have to give you. Sulfuric acid's formula is H2SO4. This tablet is really messing up today, isn't it? Aluminum sulfate. We know aluminum sulfate is Al sulfate SO4 -2. Crisscross. And then water, H2O. So our unbalanced chemical reaction would look like this. AlOH3 plus H2SO4 yields Al2SO4 3 and water. So what we're going to do is we're going to go ahead and establish our tally. So we're going to count our aluminums, our oxygens, our hydrogens, and because the SO4s that are here and here don't change, I'm also going to count sulfates. Now it is going to make us watch which oxygens we mess with, but I think we can handle this. Let's start by getting our tally. On the left-hand side, there is 1 aluminum. On the right-hand side, there are 2. On the left-hand side, oxygens that are not part of a SO4, there are 3 times 1, or 3 right here. This side, there's just the 1 that's in the water. On the left-hand side, the number of hydrogens are not part of, that are here are 2 plus another 3 for 5. And on this side, we have just 2. Now, got our sulfates. On this side, we have 1 sulfate. On this side, we have 3. So we could have counted the sulfurs and the oxygens, and I think the oxygens would have gotten a little clumsy. So we'll give that a shot. So let's fix the aluminums. Aluminums are on both sides, so if I put aluminum here, two, you get 2 there. That's going to make my aluminums be 2. It's also going to increase my number of oxygens up to 6 and increase my number of hydrogens up to 6 plus 2, that's 8. Okay. So now let's take care of our oxygens. On this side I have 6, on this side I have 1. So if I put a 6 here, I have 6 oxygens, but now I'm going to have 12 hydrogens. Okay, this is getting a little clunky, but let's see if we can fix this with the sulfates. Because it looks like hydrogens are going to be a bit of a mess. If I have 3 sulfates over here and 1 sulfate here, and I put a 3 out in front of this compound, that means I'm going to have 3 sulfates. But now look what happened. I now have, as far as hydrogens go, I have 3 times 2, or 6 here. I have 3 times 2, or 6 here, meaning I have 12 hydrogens. And guess what? World's worst smiley face, but this equation is balanced. So with the coefficients of 2, 3, 1, or invisible 1, and 6, this equation is balanced. Let's try the next one. So if I have barium hydroxide reacting with sulfuric acid, let's see, barium hydroxide, barium is a +2, hydroxide is a -1, so I need 2 of those. Sulfuric acid, we just did, H2SO4. Barium sulfate, BaSO4, and water's H2O. So our unbalanced equation would be BaSO4, BaOH2 plus H2SO4, giving me barium sulfate, BaSO4, and water. So let's tally our totals. This time I'm going to count the sulfurs and the oxygens separate across the board. Even though we still have the sulfates, I want to make this one be where I choose not to put together my polyatomic ions. So I'm going to count the bariums and the sulfurs, the hydrogens, and the oxygens. And I start by tallying what I have to begin with. So to begin with, I have one barium on each side. Cool. To start with, I have 1 sulfur on both sides. Cool. To start with, I have 2 plus 2, or 4 hydrogens, and I have 2 over here in the water. In oxygens, I have 2 plus 4, that's 6 oxygens. But over here I have 4 plus 1, or 5. So bariums are good. Sulfurs are good. Only thing's wrong is the hydrogens and the oxygens. So I fix the hydrogens by making this a 2. Terrible 2. That's a 2. Now I have 4 hydrogens. And I have 4 plus 2, 6 oxygens, and yes, he's balanced. And we get the balanced equation of a coefficient of 1, 1, 1, and 2. Sometimes they are very easy, sometimes they are not so easy. Try the next one. We've seen this one before, but we're going to do it again. Anyway. We have hydrogen reacted with oxygen to produce high dihydrogen monoxide or water. Remind you that hydrogen is a Brinkelhoff, so it has to be H2. Oxygen's a Brinkelhoff, so it's going to be O2. Again, the Brinkelhoffs. BRINCL, H, O, and F. They all get a subscript of 2 when being written by themselves. Brinkelhoff. So if I start with the non-balanced equation, and I just count my 2 atoms, hydrogen and oxygens. I start off with 2 hydrogens here, 2 hydrogens over there, 2 oxygens here, and 1 oxygen here. So I'll put a 2 here. Gives me 2 oxygens, but I've also messed up my hydrogens, but that's okay. If I put a 2 there, I get 4, and I get a balanced chemical equation with 2 and 2 and 1 being my coefficients. Let's keep going. Here I have aluminum reacted with copper nitrate. Ooh, I think it's copper 2 nitrate. Let me double check. Oh, they did copper 1 nitrate. Okay. Copper 1 nitrate. And produces copper, the metal, and aluminum nitrate. Well, aluminum is just going to be Al. Copper 1 nitrate is going to be Cu plus 1, NO3 minus 1, and aluminum nitrate, Al plus 3, nitrate, NO3, that's a minus, so I need 3 of those. So the equation unbalanced would look like that. So let's do our tallies. On the left-hand side, the reactant side, there's 1 aluminum. On the right-hand side, the product side, there's 1 aluminum. On the left-hand side, the reactant side, there is 1 copper. On the right-hand side, there is 1 copper. On the left-hand side, there is 1 nitrate. On the right-hand side, there are 3. So it's not balanced, but easy enough. If I put a 3 out in front of the copper nitrate, I get 3 nitrates and 3 coppers. And that means all I got to do is put a 3 in front of copper. And you know what that means. He's balanced. 1, 3, 3, and 1. It's a very methodical approach that you have to go through for some of these. Some of them are very easy to see. Some of them are going to be a little harder. Speaking of a little harder, we have this reaction, dicarbon hexahydride, C2H6, reacting with oxygen to produce carbon dioxide and water. So this is a pretty tough one. So if I go through this process, the reason I checked is I didn't remember setting this one up, so we do not want red. So let's see if we can do this. So I have carbons, hydrogens, and oxygens. This tally, I've got 2 carbons on the reactant side and 1 on the product side. I have 6 hydrogen on the reactant side, and I have 2 on the product side. And I have 2 oxygens on the reactant side, and I have, let's see, 2 plus 1, 3 on the oxygen side. Let's start fixing it. We have, if we put a 2 out in front of there, we're going to have 2 carbons, but now we have 4 plus 1, or 5 oxygens. We put 3 out in front of the water, that's a 3. Then I have 6 hydrogens, now I have 4 plus 3, or 7 oxygen, so we need to put that 3.5, and just like we did on the previous video, it's the same exact reaction. We get the coefficients of 2, 7, 4, and 6. We have to double everything. Last one. This is tougher, but still the same logic as this dicarbon hexahydride reaction. If I have octane, which is C8H18, it's the organic naming structure for that being octane. Reacts with oxygen to produce carbon dioxide and water. So here is my equation. And I start my tally, carbons, hydrogens, and oxygens. So we're going to have bigger numbers here. You can tell already, because on the carbon side, on the reactant side, I have 8 carbons. On the product side, I have 1. On the reaction side, I have 18 hydrogens. On the product side, I have 1. And on the reactant side, I have 2 oxygens. And on the product side, I have 3. So let's take care of carbons first. If I put an 8 here, that would make me have 8 carbons. But it also has me have 16 plus 1, or 17 oxygens. And if I change the, let's see, 2 times what is 18? That's 9. So if I put a 9 out here, that makes there be 18 hydrogens. But now I have 16 plus 9, or 25. A good spike. Where'd that come from? It was playing so nice for a while. Or 25. That is a 25. 25 oxygens. And just like the last one, I can't multiply anything times 25, anything times 2 to get to 25, but I can pretend like I can. Let's pick a number, 12.5 times 2 is 25, and we're good. But we can't use those coefficients. We got to get them all to be even numbers, so we have to multiply everything times 2, to have it become 2, 25, 16, and 18. And those are the correct coefficients for the combustion of octane. So again, the process is going, count the atoms, reactant side, product side, fix it, reactant side, product side, fix it, until it all works out. And they will work out unless you write one of your formulas incorrectly. If you write one of your formulas incorrectly, suppose for just giggles you wrote barium chloride is BaCl, you didn't put a 2 there, it's likely that that balanced equation is not going to work. So you really do need to be aware of properly writing the formulas for the compounds to have any chance at all to be able to balance a chemical equation from a word equation. So that's the end of lesson 1. Hopefully I'll get over the break. I will get lesson 2 and maybe 3, maybe even 4 and 5 done. Wishful thinking, but we'll see what happens. But until then, have a fantastic rest of your day. Toodles.